All right, let's start up here. We got 9.1 angles in standard form and radians versus degrees. Okay, so let's see. Let's start with the items in bullets here. First of all, an angle in standard form. So we're talking about just drawing angles along an axis, an XY axis. We've got X and Y, the degrees, and then we're going to have a unit of measurement called radians as well that we're going to be talking about. And before we get started, you're going to need to know how to switch back and forth on your calculator from degree mode to radian mode and so forth. Because if you have an angle that's in degrees, you need to be in degree mode when you're calculating. And if you have an angle in radians, you need to first be in radian mode. Otherwise, it's going to be all messed up. Okay. So first bullet here, it says an angle on the coordinate plane is in standard form when the vertex is on the origin, okay, and one ray lies on the positive x-axis. So this is the coordinate plane. You got on the x-axis and then some other, angle ending somewhere. The ray on the x-axis, so this side right here is called the initial side. So that's where we start. The initial side. Okay. So this positive x-axis part is where we start, the initial side. And then we go from here in this direction for however many degrees or whatever we're looking for as far as an angle goes. The other ray, so this is the initial side, this is where we start. So the other one where we end is called the terminal side. Terminate. The terminal side. Okay, the initial side and the terminal side. So if we start here at the initial side and go counterclockwise, we're going left essentially, counterclockwise, okay, we will have positive angle measures. And if you go clockwise, so if I start here, my initial side, and I go this way, down and around and around and around, okay, if I go the other direction, you're going to get negative angle measures. And then if you go all the way around, it's a circle, so one full circle, one full revolution is 360 degrees. Okay. So now when we draw angles, in drawing angles, we start at the initial side, okay? And we have to have a kind of an understanding of degree measure. So 75 degrees, if I go from the initial side to this next y-axis, okay, that's 90 degrees. So 75 is going to be less than that. So if we say, I don't know, about right to there, roughly, and then we draw the terminal side. There's my angle, and we'll label it theta, just to reference that angle. We know it's 75 degrees because we just drew it. Okay, if you wanted to be more accurate, you could pull out a measuring tool and calculate those degrees, but this is just kind of how we're going to draw angles. All right, for the next one, it's negative 160. So we're going to start at the initial side. And since it's negative, we're going to go down 160 degrees. So all the way to the other side here is 180. So we're going to go 20 degrees less. So I'm going to start here and go all the way to about there and call that the terminal side. And this is my 20-degree angle. This one over here, 75 degrees, I'll just label it. Okay, so I've got this little sliver angle there, 20 degrees, okay? And the big one here is negative 160. And what else? 430 degrees, okay. So that's larger than 360, but still, we're gonna start at the initial side. We're gonna go all the way around. That's 360. Plus how much more is gonna be 430? What, 70? So we gotta go 70 more. So we'll still end in the first quadrant. Okay, but starting here, all the way around 360 plus 70 more. So this little piece right here is 70 degrees. But the whole thing is 430 degrees. All right. So this little piece right here, just for, it's going to come up here in a little bit, but this is called a reference angle. Okay. So wherever you end, the angle that's closest to the x-axis is your reference angle, and it's always going to be we're always going to use it as a positive angle. So this would be a 20-degree reference angle. This one, since it's in the first quadrant, is 75 degrees, and this one is 70 degrees, representing 430 degrees after we drew it. Now, does everybody remember the quadrants? Up here, this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. Okay, we go counterclockwise. So we want to remember that as we're moving forward here. Okay, now we're going to shift gears here just for a second and do some calculations, and we're going to talk about radian measurement and degree measurement. So let's read what a radian is. A radian is a unit of angle measure based on arc length. So if you look at the figure over here, so it's based upon this arc length. So from here to here, like an arc along the circle. Okay, it's based upon that arc length. Now, maybe I'll get all that in the screen. There we go. A little bit better. Okay. So based on arc length, 1 radian is defined as the measure of the angle formed when the radius is equivalent to the length of the intercepted arc. When the radius is equivalent to the length of that arc, that's called 1 radian. Okay, that's where it comes from. It's just a different way of measuring angles. Okay, and the key with radians is it's always uses the value of pi. Okay, so it'll always be some value of pi. So let's see. Recall that the circumference of a circle is 2 times the radius times pi. So 360 degrees is going to be 360 degrees. So if the radius is 1, right, just as a unit of measurement, 2 pi would be how many radians you would have. So 180 degrees would just be half that. So half of 2 pi is just 1 pi. So it's just pi radians. All right, so 180 degrees is pi radians. 360 degrees is 2 pi radians. So when we convert, we just change however we need to change. So if your radians, if you want them to find radians, you take the degrees and you times it by pi radians over 180. And the other way, it's times by 180 over pi. So we'll do some of these and you'll see it's a fairly easy conversion. So if you're starting with degrees, okay, you're going to times that by, so I'll make it a fraction, times, so my answer is going to end up with pi in it. Okay, so this is how I remember. So I'm going to multiply by pi over 180. So that gives me 30 pi over 180. So I just reduce 30 over 180. And 30 over 180 reduces to pi over 6. So 30 degrees is pi over 6 radians. Okay. 150 degrees, I'm going to times that by pi over 180. So if I'm going from degrees to radians, I multiply by pi over 180. Okay? If I have degrees and I want it in radians, I multiply by pi over 180. So you can see how this goes. 150 pi over 180. I don't need to mess with pi, just leave pi. I just reduce the numbers. 150 over 180, that's going to reduce to 5 over 6. So 5 pi over 6 is how we would leave that. Radians. Negative or positive doesn't matter. Still do the same thing. So 220, I have degrees, I want to change to radians. So I want to times it by pi over 180. So now, see the fraction that's going to happen here, 220 over 180? So negative 220 over 180, what does that reduce to? So take your calculator out and reduce it. Quick way, if you have this calculator, I know it might be cheating a little bit, but if you have this calculator, I just go negative 220, or whatever number you're doing. I just do the fraction divided by 180, and I hit enter. And it gives me some decimal. And if I hit the math button, and number 1 is in a fraction, I can see, oh, the new fraction is, what is that? The lighting's a little off, but it's 11 over 9. So negative 11 over 9. And leave the pi. Okay, now if we're going to switch the other way. So if I'm going to change from radians, so I'm starting with a radian measure, and I want to change it to degrees. So I'm just going to multiply by the reciprocal, 180 over pi. So what's going to happen is the pi value is going to cancel. So if I times this by 180 over pi, you can see how the pi's will reduce. Okay? Now it's just a matter of numbers. 4 times 180 divided by 3. So 4 times 180 divided by 3, because the pi is reduced. Okay, so I don't need the pi's anymore. They cancel. That's how I know which way I'm going to end up here. Because I'm going to end up with a degree measure, so I'm not going to have pi in it. So pi goes on the bottom, because it's going to reduce. So what's 180 times 4? Just calculate this. 180 times 4, enter, divided by 3, enter, 240. So this is 240 degrees. And negative 5 pi over 36. So this is radians, because it has pi in it. So I'm going to multiply it by 180 over pi, so that the pi is reduced. Now this number I get in the end will be in degrees. So negative 5 times 180 over 36, because the pi is canceled. So I don't have that anymore. Well, it's 1, so this will be this times by 1. So negative 5 times 180, enter, divided by 36, enter, negative 25 degrees. Oh, wait. Is that right? Let me do that again. Negative 5 times 180 divided by 36. Yeah, 25. Okay. And so we'll just move on. 7 pi over 4 times by 180 over pi. So the pi's will reduce, so it's 7 times 180 divided by 4. So 7 times 180, enter, divided by 4, enter. 315, so 315 degrees. Okay, so that's converting from degrees to radians. Note, when degrees to radians, you're going to multiply by pi over 180, so that in the end, your answer has some fraction with pi. Okay? If you're going from radians to degrees, you times by 180 over pi, so the pi value cancels, and you end up with just a number. And don't forget your degrees symbol, because that will tell you what unit of measurement you're in, is degrees. Okay? All right, let's turn over to page 3. Okay, this term here called coterminal, that means two angles, or multiple angles, that terminate or end at the same place. So for example, if I started here and I went to, let's say 90 degrees, like it's showing here. Okay, I went to 90 degrees, or pi over 2 radians. Okay, that's where I ended. Okay, but if I started here and went the other direction and ended at the same place, that would be a negative 270 degrees. So those both ended at the same terminal side. So those two angles are coterminal, 90 degrees and negative 270 degrees. Would both be coterminal because they end at the same place. And if you're using radians, you know that 180 degrees is pi radians, so half of that, which is 90 degrees, would be half of pi over 2. And going the other way, if you went 3 quadrants, 90, 180, 270, or 1 pi and a half, which would be 3 over 2 pi. That's kind of where that comes from. Or you can do the conversion. Okay, so how do we figure out where, coterminal angles? Well, what do we do here? We went in the positive direction, okay? And we went also from where we started in the negative direction, okay? If I wanted another positive coterminal angle, I could go all the way around again. So if I start here and I go to 90, and then I just keep going 360 more, I would end there again. So 90 plus my 360 would give me another coterminal angle, and I could just keep going, 360 again, 360 again, 360 again, for as many times as I want to find positive coterminal angles. Starting here and going negatively, I get, a coterminal angle, negative 270, and then I could go a negative 360 and negative 360. So there's an infinite number of coterminal angles. But it's quickly figured out when you start with a certain angle and you want a coterminal angle. So it says give two coterminal angles, one positive, one negative. So if I take the angle, whatever it was, and go 360 more, so 65 plus 360, so I started at the 65 degree angle and then went 360 more, that would give me a coterminal angle of 425 degrees. Okay, now, starting here, notice I didn't start at the 90, I started here, and I went negatively until I hit that same spot. So if I had this, so for the 65 degree one, just a quick sketch here, 65, if I started here and went to there, that would be my negative coterminal angle. So how do I figure that out? Well, the whole circle is 360, and I'm just minus this 65. So if I take my angle that I'm using, and if I subtract 360, that will give you my negative coterminal angle. And this one is negative 295. So 540. So with that in mind, if you go to 540 and then add 360, you're going to get a coterminal angle. This should be 900. Now, since this one's already wrapping around to 360, you could have you could say, okay, well, that angle minus 360, that's going to be 180. So that's a positive one. That's not a negative one. So if 180 is the same, I guess you could go 180 minus 360. That would give you negative 180. That would be a negative coterminal angle. So let's look at it. So 540 would be 360 plus 180 more, right? So this is our terminal side. Okay, so if we go negatively to that point, negative 180 would be my negative reference angle, or not reference angle, but negative coterminal angle. (13pi/18). All right, so this is a little tricky. I'm going to maybe get another piece of paper. Just to talk about you have to kind of be able to talk in fractions a little bit. You know that if you look at the denominator, it's 13pi/18. Okay, so 18 is my denominator. So essentially I'm taking this axis and I'm dividing it into fractions of 18. So if I know that from here to here is 1 pi radians, okay, that would equal 18/18 pi. Okay, I only want 13 out of 18. So where's that going to fit? Well, what's halfway? Halfway is pi/2. All right, pi/2 radians. So what's half of 18? 9. So that's 9/18 pi radians. So from here to here then would be 9. So I need 4 more. So I would just go roughly 4 more. And that would be so let's draw it down here. 9/18, 13/18. So there is my terminal side. And that would be, this big angle would be 13 pi/18 radians. Well, how much is left? What's my reference angle? Well, how much left is it from 18? This would be 5 pi/18. So my reference angle is 5 pi/18, but my initial angle is 13 pi/18. Okay, so if we're going to then find coterminal angles, we're going to take 13 pi/18 and we're going to add 360. Well, what's 360? 360 is 2 pi, right? 360 degrees is 2 pi radians. Okay. So back up to here, 1 pi is 18/18. So 2 pi is going to be 36/18. So we're going to add 36/18. So 36 plus 13 is 49 pi/18. And if that reduces, that reduces. So 13 pi/18, we're going to add 360 degrees, which is 36/18 pi, which is 49 pi/18. And then the same thing, if we take 13 pi/18 and subtract 360, which is 36 pi/18, like we did on the others. So 13 pi/18 minus 36 pi/18. 13 minus 36, that's what, 23? So negative 23 pi/18 would be my other coterminal angle. And we keep it over 18 because it's fractions, right? We don't change the denominator. All right, 14 pi over 9. So we're going to add 360, which is 36 pi. Wait, not 36 pi. Oh, forgot the denominator. So the denominator is 9. Okay, so if I'm adding 2 pi, all right, this is going to be 18 over 9. That's 2 pi. So I'm adding 360, which is 2 pi. 14 plus 18 is 32 pi over 9. And I don't think that reduces. And if we subtract 2 pi, or 360 degrees, denominator is 9, so it's 18 over 9. 14 minus 18 is negative 4. So negative 4 pi over 9. Okay, so with radians, it's just a little tricky because you have to understand the fraction, and that your denominator determines what your fraction is going to be as far as adding 2 pi or subtracting 2 pi. Okay, we talked about reference angle. Reference angle, let's read, for any angle in standard form. The reference angle, so for any angle, no matter where it is, okay, the reference angle is the positive acute angle formed by the terminal side and the x-axis. So essentially, you draw your angle, okay, and then you look at the x-axis. The shortest route from the x-axis to that terminal side is your reference angle. Okay, so it's going to be acute, it's going to be less than 90, and it's going to be in one of these 4 quadrants depending upon your angle. So if we draw this one, all the way to here, then we say, okay, from x-axis to there is my reference angle. And we always use the positive angle measure value for the reference angle. So let's draw 225 degrees. So we know that's bigger than 180. How much bigger? 45? So 45 would be about halfway in the next one. So if I go 90, 180, and then 45 more, okay, I've drawn my 225 degrees. Now how far is it from the x-axis to this terminal side? I think we mentioned it earlier, 180 plus 45, so 45 degrees is my reference angle. Negative 310. So negative 360 is all the way around. Okay, so if I go to, so 310 would be in what quadrant then? 360 minus 310 would be 50. So I've got to go to 310 and then 50 more. So let's go negative 310, roughly about there, because that leaves me 50 more degrees to get back to 360. So my angle is negative 310, but from the x-axis to that terminal side is 50 degrees, because that's how much was left to get back to here. 310, how much more to get back to 360? Oh, 50 degrees. So 50 degrees is my reference angle. Now 2 pi over 3. So this is tricky because this is all fractions. So 2 pi over 3, that's 2/3 of 1. So we're going 2/3 of the way. 1 pi is 180 degrees. So 2/3 of the way. So if you took this whole section and divided it into 3 groups, 1, 2, 3 roughly, okay, 2/3 would be about right here. 1/3, 1/3, and another third. Okay, so 2/3 would end here. So how much is left? So if I went 2/3, how many more thirds do I need to get to 1? Because 1 is 180. It would just be 1/3. So that reference angle is pi over 3. So I went 2/3, and then 1/3 more to get back to the x-axis. And so the tricky part about radians is understanding the fraction. So you have to look at the denominator, and that's how you're going to break up the circle. So just some extra, I don't know, if I were in sixths, let's say I had 5/6 pi. So all the way to here would be 6/6. So if I had to stop at 5/6, I would stop a little bit less. I would stop 1/6 less, right? Or if this were 11/12 pi, okay, 11/12, well, this would be 12/12, so it'd be, I don't know, 1/12 less. So it'd be pi over 12. It's just kind of how that goes. Okay. Now, trig functions. I think the next page is your assignment. Okay. So this is the end of our notes. This is page 3. Trig functions, where are we? Let's so our angle, okay, so let theta be an angle in standard form. Okay, so if we have a xy axis, we're going to have an x direction, a y direction, and then this line here, our terminal side, is the radius of some right triangle that we're going to draw. Okay, so if I start here and I just go to the terminal side here and I draw my terminal side, okay, and then from that side right there, that terminal side, if I just drop down to the x-axis, and then the piece of the x-axis, I've created a right triangle. Okay? Now, depending upon the quadrant, will depend upon whether these x's and y's are negative or positive. So this would actually be negative x and positive y. So this is the radius. Okay? Now, the Pythagorean theorem says that this length squared plus this length squared equals the hypotenuse squared, which we'll call the radius. So we now have our right triangle in terms of x direction, y direction, and radius, x, y, and r. And we use the reference angle when determining our trig functions. Okay, so sine of theta, we're not using this big angle, but we are, but the reference or the value or the ratio is going to be the same as the reference angle. So we use the reference angle. So the sine is the side opposite over hypotenuse. So this would be y over r. Cosine, if I quickly draw where that triangle is, okay, cosine is going to be adjacent over hypotenuse. So adjacent is negative x. And if I had an exact value. But for now, we'll just say it's the x value over the radius, because it's not always going to be in the second quadrant. Okay? We could, if it was in the first quadrant, it'd be positive x. So this is just in general, okay? And then if we have a specific triangle in a specific quadrant, then we can assign positive and negative values to x and y as needed. Tangent then is going to be opposite over adjacent, so y over x. So now our, instead of saying opposite over adjacent, okay, we're going to use x, y, and r. But it's the same thing. Okay? If you want to go say opposite over adjacent and then just fill in the letter, that's what you should do. So these are now the reciprocals, and we move on. So this is how this works. So you take a coordinate point. So it says we have this coordinate point, 5, -2. It's a point on the terminal side. Okay, so if you go to 5, negative 2. So this is 5 this way and negative 2 this way. So this is 5 and this is negative 2. Then draw your hypotenuse, r. Okay, we can find r. You do 5 squared plus negative 2 squared, which is going to be positive 4, equals r squared. So 25 plus 4 equals r squared. R squared equals 29. So r is the square root of 29. So I would say square root 29 right there. Okay, so this is what you do. You plot your point, okay, then you value the x direction and value the y direction to that point. There's your x, there's your y, and then you use the Pythagorean theorem to find the radius. Okay, so sine, using the reference angle, sine is opposite over hypotenuse. So that's negative 2 over the square root of 29. And then we simplify by timesing by the denominator. And negative 2 square root 29 over 29 is our final value. Okay, it's finding the exact value. Write it like this. Cosine, that would be adjacent over hypotenuse. So 5 over the square root of 29 times by the square root of 29 times by the square root of 29. 5 square root 29 over 29. Tangent, opposite over adjacent, so negative 2 over 5. Cosecant, we just flip this. So I'm going to go to the original one, negative 2 over square root of 29. Just flip it. Square root of 29 over 2, and it's negative. Secant, flip this one. Square root of 29 over 5. Cotangent, flip that one. 5 over 2, and it's negative. Okay? So we draw the triangle. Okay, so pages 4 and 5 are yours. Until next.